we're back now with Terrence Howard. It's in the last video he was kind of explaining, the thing that he thinks about DNA and I don't know, music chord progression or something. Let's see.
Instead of hitting as an F sharp, it hits as an F, so when it hits the carbon at an E, it doesn't hit it quite right, so the domino don't file right. So the next domino hits wrong. And so now we have malformation happening within our DNA because
malformation.
The frequencies are being pushed off. But when we hear our tone, we tighten back up. So yeah, I'm in the process of building a harmonic wave resequencer with another doctor who has been able to successfully cure AIDS and cancer.
He has been able to successfully cure AIDS and cancer with this harmonic wave resequencer.
And it's well underway.
Oh, it's well underway. It's well underway. By the way, this talk was from this video was posted in 2017, and it's 2024, so that's 7 years ago. And the guy in the audience asked him about him talking about this 5 years prior to that. So now we're talking 12 years, and just absolutely no progress on this harmonic wave resequencer, which is a shame because I would definitely buy one. Especially if it came in the box with like Terrence Howard's face on it.
But I wanted you guys to understand how that works. It's so simple. You do not need to tear the human body apart when all you can do is use frequency to bring it back to its normal space.
Just use frequency, whatever that means. Just use frequency. Yep. What you guys, when you do the surgery, like exactly was? Oh yeah, we just used frequency. Oh, okay, cool.
Great, thank you for that question. Yeah, that's good.
Great question. Yeah, I think what's important too, moving forward in this talk, is looking at the audience and looking at their expressions, and especially when I pause it like this, it's like, and it's starting to turn on them a little bit. If they weren't already.
Thank you so much. I've always been interested in acting, so it's pretty cool to be in the presence of an actor. But my question actually has to do with your numbers theory. So if by your logic you say 1 times 1 equals 2, are you insinuating that 1 times 0 then equals 1?
Equals 1. Well, that's what we were saying with the identity principle, the identity property.
Again, great question from the audience. And that's something that comes up a lot because he's always like, what 1 times 1 is 2. So then people, one of the best follow-up questions that you can ask to that is, well, what's 1 times 3 or 1 times 4? Like, what's, So she's asking, well, does that mean 1 times 0 equals 1? And he seemed to say yes. He was like, you're right. 1 times 0 is equal to 1.
It says that 1 times nothing equals nothing.
Hold on. Let's go back for a second here.
Are you insinuating that 1 times 0 then equals 1?
Equals 1. Well, that's what we were saying with the identity principle, the identity property. It says that 1 times nothing equals nothing.
Okay, that's not the identity property. That is, what do they call that? The zero property of multiplication, or the multiplication property of 0. It's definitely not the identity property. The identity property is that anything times 1 equals itself. A times 1 equals A, where A is any member of whatever field you're looking at, or group, or other abstract algebraic structure. And it works for the reals, it works for complex numbers, for a lot of things, but what he's quoting, he's misquoting. He's arguing against something, and again, he's misquoting it. So he doesn't understand what he's even against.
So now you have the laws of physics have to now adjust because
Explain.
Something just disappeared. Conservation of energy. Energy can't be created or destroyed. So if 1 times 0 equals 0, then what happened to the energy of the 1?
Well, what energy? What are you talking about? Like, what does that mean? One does not have energy. First of all, numbers are not tangible. They are abstract concepts which represent quantity and or other types of measurement. But they're not. It's not like you can go visit the number one. It doesn't actually exist. It's not tangible. So what energy are you talking about? Because you can't have energy coming from, words and stuff, ideas, concepts, abstract concepts. That's what numbers are. So that's such a stupid argument. What happened to the energy of the one? What energy? What do you? People throw around the word energy a lot, and it really bugs me sometimes.
Isn't that the same problem that Stephen Hawkins was talking about with the event horizon?
Stephen Hawkins. Oh, look at this guy now. Like I said, take a look at the audience. See if they're on his side or not. Let's just judge for ourselves.
And the information going in and still being present, that conflict that was started, well, that's because of the math. The principles in the math are not founded on truth. It's not founded on substance.
What? If anything, if any subject out there, besides maybe philosophy, is defined as being completely based on truth, it's mathematics. I used to tell students, math is basically the study of truth. We were talking about logic. So we're looking at one thing as being true, and this other thing is true, and you can prove things using, rules of inference and logical equivalences and De Morgan's law and things like that. So it's basically the study of truth. It's what is true versus what is not true, provably. So I don't know what he means when he says math is not founded on truth. The other thing I mentioned was philosophy, but that's more of in the humanities, and it's, a social science, whatever you want to call it. Whereas math is literally every single thing. When you get into like college level math, every single thing is proof. It's like, how do you prove this? We have a theorem here. We got some axioms. Let's prove it. It becomes completely about logical proof. And Terrence Howard has demonstrated for all of us that he has no idea what he's doing when it comes to logical proof.
The identity principle, anything times 0 is 0, and anything times 1 is 1.
Okay, so first of all, anything times 0 is 0 is not the identity principle. Again, you've misquoted it. It's that anything times 1 is itself. Then you just said anything times 1 is 1, which is also not true. But it's difficult to tell if you're just misspeaking. You're just saying the wrong words when you mean something different, or you're really saying this because you say crazy shit like 1 times 1 equals 2, and it's not just you misspeaking.
Where is that number? Where is that exemplified in nature?
Where's it? Where's anything times 0 equals 0? Where's that exemplified in nature? I don't know. There's too many examples to name, but okay. So I'm allergic to pecans, right? So if you consider all of the world's supply of pecans, I don't have any pecans. So you can say I have 0% of the world's supply of pecans. Maybe one of the big like nut companies or whatever has like, X percentage of the world's supply of pecans. I have 0%. I do not have any pecans. Again, it's a description. It's like words. It's a description. Like, what are you arguing against here? That you can't multiply by 0? Multiplying by 0 just means you don't have any of it.
Or in universal phenomena. Is it? Do you see that?
So then, are you saying that 1 times 5 would be 6?
Yeah. Well, what does it say?
Okay, so he said yes. So 1 times 5 is 6. Again, without any proof, without any context, what are you talking about? What does this mean?
In the associative and commutative thing.
So you're
The associative and commutative thing. Yeah, you mean the associative property and the commutative property, which again apply to abstract algebraic structures, like fields, and which I can explain right now because I'm pretty sure he's about to misquote it. Commutative property basically says that you can, say you're talking about multiplication. Commutative property says you can multiply two quantities, it doesn't matter the order. So like 4 times 5 is equal to 5 times 4. Or if you want to get general with it, A times B equals B times A. And the associative property is a little bit different. It's when you have a series of one single operation, like let's say multiplication. Say you have like A times B times C. It's the same thing if you multiply A times B, take that result, then multiply by C, versus if you were to multiply B times C and then take that result and then multiply it by A. So it's like if you have a chain of the operation, it doesn't matter what order you perform that operation in. So that's the associative and commutative properties. They're very important. Let's see what he's got to say about them. Or as he puts it, the associative and commutative thing. Let's rewind a little bit.
Saying that 1 times 5 would be 6?
Yes. Well, what does it say in the associative and commutative thing?
So you're
if A and B
proposing-
are positive integers, it says if A and B are positive integers, A is to be added to itself as many times as is indicated by units in B.
So you're not
Okay, wait. So that's the definition of multiplication. So that has nothing to do with the associative and commutative thing. The associative property and the commutative property, which again are not the same property. I think he thinks that they're the same thing. He just says, "Oh, that associative and commutative thing." Yeah, that thing. No, they're two very separate properties. And in fact, you can have groups and fields that are associative but not necessarily commutative. For example, like matrix multiplication. Matrix multiplication is not commutative, as in A times B does not always equal B times A, and not everything's invertible and different stuff like that. So, those of us have studied math. I've taken a course in linear algebra, so I know that about matrices. It's so ridiculous that he presents this as being some sort of like lecture to Oxford about his physics or whatever, when really they just invited him there to talk about acting, and they probably knew that he was going to go off the rails and do weird shit like this. And when he's faced with actual real questions from the crowd, he gets actually really defensive. If you notice, he gets kind of angry. Rewind a little bit.
A and B are positive integers. It says if A and B are positive integers, A is to be added to itself as many times as is indicated by units in B.
He's misquoting here.
So
That's not
you're not proposing
those
an
properties.
audit. You're proposing like a
Well, I'm not the first one
reconstruction
to
of
say
the way
need
we
to do
understand
that.
math.
You know what's interesting? In 1856, a man from Liverpool named Richard Dover Statter challenged the Dewey Decimal System and said that it was wrong.
Okay, wait. Hold on. The Dewey Decimal System, if I'm not mistaken, is a it's like a library classification system where they use it to put certain books of similar genres or fiction, nonfiction, or whatever. That's what the Dewey Decimal System is. This guy Richard Dover Statter did write some material, and I think what he was proposing was actually like a switch more toward like a different base numbering system. So if you think about like computers, they use binary, base 2, or hexadecimal, base 16, and we commonly count and use digits. We use 10 digits, and we have powers of 10 for our place value. I think what Richard Dover Statter was arguing for, at least in certain ways, was transition to like a base 12. And it makes a lot more sense because, again, 12 is a very abundant number. It has a lot of factors. So 12 is very divisible by other numbers, which is why... It's one of the reasons why our clocks run based on 12s. So when you have a quarter of an hour, then you have 3 5-minute periods, and then it runs on 60s, and it runs on 12s, and It's because those numbers, or 360 is another good example of numbers that have been used, for many years because of they're highly divisible. Why are there 360 degrees in a complete circle? Because you can divide it up a lot without decimals and fractions and stuff. So I think that's what this guy Richard Dover Statter was writing about, and about, I don't know. We can't even get Americans nowadays to switch to the metric system, so we're not going to get everyone to switch to a base 12 numbering system. It's just not practical.
And created an entirely new system to show how it can be brought into correction. So I'm not the first person to state this. It's a number of people did it, but look up Richard Dover Statter. Try and find him. You won't find him because he did.
I found him. It wasn't that hard to find him either. You just Google him. And he's always been erased from history. No, it's just that it was, it was kind of cool, but it was impractical. Much like Terrence Howard and his drone stuff, it's like, oh, that's kind of a cool little drone design, but it's impractical. It's, it's not useful for anything. And so, again, he's trying to make this argument like, oh, he's been erased from history, and trying to, buy into all that conspiracy stuff. Whereas I found the guy, he wrote a book, it was alright. Same thing with, Terrence Howard's biggest inspiration, Walter Russell. You can find his books and stuff online. They're mostly gibberish. But, yeah, base 12 versus base 10. Sure, I actually agree with that. I think base 12 is amazing. But you're not going to get the entire world to switch to a different numbering base. There's no way.
Been erased from history almost. But what is the thing called, honey? Dewey Decimal System as a whole. The Dewey Decimal System as a whole. And you will...
He means the decimal system. It's not the Dewey Decimal System. Again, the Dewey Decimal System is something that they use in libraries to, organize books.
That we are headed to, the Titanic is headed to an iceberg over there with our numbers. If we don't make a change soon, we're going to crash as a species because our math needs to work in order for our...
You know what? The whole Richard Dover Statter base 12 stuff doesn't even have anything to do with his 1 times 1 equals 2 and all that.